Welcome to this video of another set of 10 CWI Part A questions. These are random questions with explanations provided that will guide you in your preparation for the CWI exam. So let's not waste any of your time and go into the video.
A material's ductility is commonly expressed in terms of A. Percent elongation and reduction of area. B. Width and thickness. C. Tensile strength and yield strength. D. Toughness. E. Fatigue. Ductility, by definition, is a measure of how much the material can elongate before it ultimately breaks. So for the choices here, letter B is just the measurement, so it doesn't really relate to ductility. Letter C, tensile strength and yield strength, is just the ultimate strength and the yield strength and doesn't measure the ductility of the material. Letter D, toughness, is the resistance of material against impact. And letter E, fatigue, refers to the effect of the repetitive loads imposed to the material. So by definition that I've mentioned earlier, ductility is measured by how much a specimen elongates before it breaks, hence the reduction of area here. The higher these ratio, the percent elongation and reduction of area, the more ductile the material is. So the answer here is letter A. Who is responsible for verifying welding procedures have been properly qualified? Letter A, independent test lab. Letter B, contractor. Letter C, welding inspector. Letter D, architect. Letter E, engineer. So this question pertains to who is responsible for verifying welding procedures. So this is normally a job of a welding inspector. So for the choices here, the independent test lab is just responsible for testing the samples and providing a recommendation if it passed or failed. The choice for the contractor here is a bit general. So the contractor can do a lot of things here. So the architect and engineers are responsible for the design and not verifying the weld procedures. So the answer here is letter C, welding inspector. What MT technique could be used for the discovery of longitudinal flaws? So MT means magnetic particle testing. So letter A, coil shot. Letter B, circular magnetization. Letter C, longitudinal magnetization. Letter D, parallel magnetism. Letter E, using a central conductor. So coil shot here is when using a stationary empty machine and electricity passes through that conductor, the magnetic field is created. So longitudinal magnetization is produced from the yoke method as seen here. This is the yoke method. Circular magnetization is used to detect longitudinal flaws. Longitudinal magnetization is for transverse flaws. So if you use circular magnetization, you will not be able to detect transverse flaws, and longitudinal magnetization cannot detect longitudinal flaws. So the answer here is letter B, circular magnetization. Which code gives pre-qualified status to certain weld joint configuration? Letter A, API 1104. Letter B, AWSD 1.1. Letter C, AWSD 17.1. Letter D, NSI B31.1. Letter E, AWS B2.1. So let's just run through the codes here. So API 1104 is for pipelines of oil and gas and petrochemical industries. Mainly pertains to the welding of those pipelines. Letter C, AWS D17.1 refers to the specification for fusion welding in aerospace applications. So this is for the airline industry. ANSI B31.1 is for power piping. This is mainly for power plants. AWS B2.1 is for specification for welding procedure and performance qualification. Standard for any other material with no governing specification. But this code does not give pre-qualified status. So if you have any material here that was not being covered by any other welding standard, you can use AWS B2.1. So the only standard or the only code here that gives pre-qualified status is AWSD 1.1, the welding code for structural steel. AWSD 1.1 welding code for structural steel gives pre-qualified status to certain weld configuration and is found in its clause 3. So the answer here is letter B. Information that appears to the right of the weld symbol refers to the A. Process to be used. B. Type of electrode to be used. C. Length of weld required. D. Size of weld required. E. Required joint configuration. So let's run through the choices here. So what is the information that appears to the right of the weld symbol? So the process to be used for welding appears in the tail. It is indicated in the tail of the welding symbol. The type of electrode to be used can also be indicated in the tail. The size of the weld appears on the left, not on the right of the weld symbol. The required joint configuration can be indicated in the tail, but the weld symbol kind of implies this joint configuration. So the answer here is letter C. The length of weld required is or does appear in the right side of the weld symbol. By the way, I just want to take a break from the video and remind you of the free Udemy course that I've put in the description down below. So it composes of CWI Part A lectures, the introduction for welding inspectors. So you can check out the description below for that free Udemy course. Now back to the video. The position on a metal stress strain curve referring to its changes in behavior from elastic to plastic is the letter A, yield point, letter B, modulus of elasticity, letter C, endurance limit, letter D, transformation temperature, letter E, Young's modulus. So for letter B here, modulus of elasticity is defined as the stress over strain. It is the slope here, as you can see, the slope of the proportional limit up to the proportional limit here. So it is just the slope of the proportional limit as defined by or as calculated by dividing the stress value over the strain. Endurance limit relates to the allowed repeated loads that the material can take. So if the material is subjected to repeated loads, thus under fatigue, this it can be or the endurance limit must not be reached in order for that material not to exceed its fatigue limit or not to experience fatigue failure. The transformation temperature is just the temperature that the metal will experience during its phase change. And the Young's modulus is basically the same as the modulus of elasticity. So the answer here is the point that uh, where the material changes from elastic to plastic is the yield point right here. So the yield point is where the material changed from elastic to plastic. So meaning if the load experienced by the material exceeded the yield point, it will no longer return to its original form, thus the plastic deformation here. So the answer in this question is letter A, yield point. Low hydrogen electrodes can be properly identified by which digit of a classification number? Letter A, first digit. Letter B, second digit. C, first and second together. Letter D, second to the last digit. Letter E, last digit. So this characteristic can be found in the electrode's last digit. Letter E. It is denoted by numbers 5, 6, or 8, which denotes low hydrogen or the electrodes contain low hydrogen characteristics. So the digits denote different identification for different welding processes, but the notation for low hydrogen content is still in the last digit. So the answer here is letter E. All welding symbols information referring to the arrow side of the joint is found A in the tail, B above the reference line, C below the reference line, D in a note, E to the left of the weld symbol. So the tail denotes other welding information. So for letter A, the tail denotes other welding information such as process, electrode, procedure, even reference drawings you can put in the tail. Above the reference line is for the other side of the joint, not the arrow side. So notes can be done in the tail as well. Left of the welding symbol typically denotes the size of the weld. So as you can see here, the arrow side, if the weld is on the arrow side, right here, it is below the reference line. So the answer here is letter C. Empty or magnetic particle testing can be used effectively to inspect which of the following metals? Letter A, welds on A36 steel. B, steel welds on steel Steel welds on stainless steel plate. C. Welds on aluminum. D. Welds on alloy materials. Letter E. Materials properly qualified for use with E308 electrodes. So MT can be effectively be used for ferrous metals, in this case A36. So A36 is a kind of structural steel. Welds on stainless steel or welds on steel welds on stainless steel plate might be problematic, especially for non-ferrous stainless steel because they lack iron. Or for austenitic stainless steels, for example, they don't have iron in itself. So magnetic particle testing will not work on that. Welds on aluminum definitely because iron almost is non-existent on aluminum. That's why it's not rusting, right? MT will not be effective on inspecting defects or discontinuities in aluminum. Alloy materials here are a little vague here, but the rule of thumb is that the material must contain iron for MT to work properly. The last choice here is that E308 electrode is for low carbon material specification. This electrode is for low carbon steels. And this does not relate to the question being asked. So the answer here is letter A. Since MT will work on ferrous or will work effectively on ferrous metals, and A36 is a ferrous metal containing iron. The use of preheat on a medium carbon steel weld test plate will perform all of the following except letter A, reduce distortion. Letter B, reduce the possibility of hydrogen cracking. Letter C, result in the formation of martensite. Letter D, produce a wide heat affected zone. Letter E, diffuse hydrogen. So what happens when you preheat a medium carbon steel? Preheat can reduce distortion since the material will not result in sudden change in temperature. So if you preheat that material, when you weld it, it will not be subjected to a sudden change in temperature due to its exposure to the atmosphere, or if you subject it to post weld heat treatment. So for letter B as well, it will be to reduce the possibility of hydrogen cracking. So the material will have that reduction of possibility because cracks will not happen because preheat will improve its grain property. And because of a larger heat input, basically preheating will have a larger heat input on the material prior welding. It will produce a wider heat affected zone or HAZ. And since we have a larger heat input than normal, it will diffuse hydrogen because the heat will increase the kinetic energy of hydrogen molecules, thus increasing its speed and diffusing them to the atmosphere. So the answer here is letter C, result in the formation of martensite. So preheat will not result in the formation of martensite since these martensite are formed when rapid cooling of metals are done through like quenching as part of making the metal harder, but in its consequence making it more brittle. Martensite makes the metal more brittle because it results in a coarser grain structure when you subject the material in a rapid cooling phase after heating or after welding it. If you see the coarse grain structure that is produced by martensite, if you see it in a microscope, it resembles a broken glass. So it is somewhat synonymous to the metal being brittle.